So, good evening, everyone. I would like to explain few important lines of Group 15 elements. Okay, I bring my NCERT textbook from that sofa. So, dear students, okay, now if you are listening to this, uh, I just wanted to make this available for all the students, those who wanted to listen from my side. Group 15 elements. This comes in class 12 in organic chemistry, P block elements. In 3-4 sessions, we'll complete group 15. Group 15 is very important. Latest JE 2022 advance also there is a question on heating lead nitrates. That question is from this topic only. So what are the elements of group 15, what they are called and all. That's just like a casual discussion will go. Fine. So first of all, nitrogen, phosphorus, arsenic, antimony, bismuth and moscovium. Nitrogen, phosphorus, arsenic, antimony, bismuth, moscovium. These are group 15 elements. Of these elements, nitrogen, phosphorus are non-metals, arsenic, antimony are metalloids, bismuth is pure metal. Okay. And about moscovium, we don't discuss much because its chemistry is not known properly. It's an artificial element, you can say. So nitrogen. Nitrogen is diatomic, N2. Okay. Phosphorus, arsenic, antimony are tetraatomic, P4, AS4, Sb4, and bismuth is monoatomic. Of this, nitrogen can't show any allotropy. You can come, no problem. Nitrogen can't show any allotropy. Nitrogen is uh, generally gas, so gas cannot show allotropy. But when you convert this into solid, this is given in other books, not in NCERT. When this is converted into solid, then you can expect there alpha and beta two forms, alpha nitrogen, beta nitrogen in the solid form. But according to NCERT, except nitrogen, remaining molecules show the allotropy. Nitrogen, phosphorus, arsenic, antimony, bismuth. And only phosphorus forms are given: white phosphorus, red phosphorus, and yellow phosphorus. Yellow phosphorus is there, but in your NCERT it is mentioned black phosphorus. So about this, nitrogen, phosphorus, arsenic, antimony, bismuth. About all these properties we are going to discuss. Down the group, atomic radius should increase, and atomic radius definitely increases. Down the group, atomic radius increases. Okay, as usual. But when it comes to the ionic radius, interestingly, nitrogen, phosphorus, arsenic, antimony. Antimony's ionic radius is very small. Very small. According to NCERT value, it is very small. So note this point. Okay, NCERT is your Bible. You need to remember every line of NCERT in details. Otherwise, you are going to make some mess. Okay, so that point. Then ionization potential 1, ionization potential 2, ionization potential 3, IP1, IP2, IP3, all this. Down the group, ionization potential should decrease. And same thing happens. Highest is for nitrogen, then phosphorus, then arsenic, then antimony, then bismuth. So IP1, IP2, IP3, all these to decrease, they are decreasing. As nitrogen, phosphorus are electron, that is non-metals, for them only we can discuss electron affinities. Okay, so electron affinity of nitrogen is less because of field stability. Phosphorus is also less. But when you compare nitrogen and phosphorus, when you compare, phosphorus is better than nitrogen. This is your question. Phosphorus is better than nitrogen in electron affinity. Electron affinity of phosphorus is more than nitrogen. First question of this category. Nitrogen and phosphorus. Electron affinities. Coming to the electronegativities. Electronegativity of nitrogen is 3.0. Okay, electronegativity of phosphorus is 2.1. Sudden drop. Then 2.1, then 2.0, then 1.9, 1.93, 2.1, 2.0, 1.9, 1.9. What's happening here? Down the group decreases. Highest is for nitrogen, then phosphorus 2.1, then antimony. Finally, we are coming to bismuth 1.9. Down the group, electronegativity decreases. Last two elements are having same. You can give that reason for the inert pair effect. All the reasons you can mention, as we are discussing in case of group 13, group 14 also. Okay. last element, when it is same, you can say that is because of the inert benefit. So that's about electron negativities, electron affinities, ionization potentials, atomic radius, and now densities. Now in the group, density should obviously density should increase. Densities increases. Densities must increase. Boiling points, when you see boiling points, nitrogen, phosphorus, arsenic, antimony, up to antimony increases, then sudden decrease. Bismuth, slight decrease is there. Melting points, nitrogen, phosphorus, arsenic increases, then decrease. Okay, these are NCRT based values. I have NCRT. Okay, but we remember these values. Then coming to just let me check whether I'm saying right or wrong. Okay, melting point 63, right. Boiling point, right. So densities done. Then coming to the next thing, that is general properties we are discussing. Nitrogen is N triple bond N. Because of this N triple bond N, it is very less reactive. Nitrogen is non-poisonous, nitrogen is colorless, nitrogen is odorless, nitrogen is tasteless. We are inhaling nitrogen and nothing will happen. Nitrogen is a colorless, non-poisonous, colorless, odorless, tasteless gas. Nitrogen, triple bond is there. Good evening, Mr. Abhinav. When triple bond is there, the bond energy is approximately 941.4 kilojoules per mole. This is very huge bond energy. When this high bond energy is present, nitrogen is very less reactive. The reason for the nitrogen's less reactivity is triple bond. And another important property of nitrogen is nitrogen can form multiple bonds with other nitrogen atoms, of course carbon atoms and also oxygen atoms also. P-pi bonds are possible for nitrogen. Nitrogen can form p-pi bonds. This is like anomalous property of the first element. We generally say second period elements and third period elements, when you compare, second period elements will have some abnormal behavior, okay, anomalous behavior. That is because of non-availability of the vacant d orbitals, small size, high electronegativity. So because of all these reasons, there will be some dissimilarities with other group elements, and one of them is p-pi bonding, nitrogen oxygen, nitrogen carbon. P-pi bonds are possible, which are not possible for the phosphorus. Phosphorus may also form, but not very easily, not very comfortably, not very. Sir, can you post a video regarding stoichiometry, balancing of equations? So many are there, beta. So many are there. Yesterday only I mentioned. You can check what you say, balancing of equations in basic medium, acidic medium. Many are there. You just check. Otherwise, you just go with the what you say playlist stoichiometry. So many are there. Okay, now I taught yesterday also. I have posted. You just check. Okay. Otherwise, later you just ping me. I will send you the link. Then, so coming to the general properties. So nitrogen is a diatomic gas we were discussing. Phosphorus is a tetraatomic solid. Phosphorus solid, arsenic solid, antimony solid. Bismuth is again monoatomic. Okay, now monoatomic metal. So nitrogen, phosphorus are non-metals. Arsenic, antimony are metalloids, and bismuth is metal. Just go on listening carefully. After listening to this, I don't think so that you will have any doubts, and no need to refer any book or something. Directly you can attempt all the questions. Any institute across India. Okay, be confident. The reason is you need to be perfect in the NCRT only. NCRT will be giving very few lines. So coming to compounds of these, after general properties, compounds of this. In compounds of this, we have first hydrides: NH3, PH3, ASH3, SBH3, BiH3. NH3 is called ammonia. PH3 phosphine, ASH3 arsine, SBH3 stibine, and BH3 is bismuthine. When these compounds are present, 6-7 special properties are there. We need to be very good about them. First property is stability. Ammonia is more stable. Down the group, stability decreases. Ammonia more stable. Down the group, stability decreases. So bond energy, same thing. Bond energy is maximum for ammonia. Down the group decreases. Bond length, reverse. Bond energy, bond length are inversely proportional. So when bond energy is more, bond length is less, so down the group bond length increases. Coming to very special property of what is a bond angles, right? Bond angles, when you see ammonia bond angle is 107, rest all are very close to 90 degrees. Okay, 94, 92, like that the angles will be there, close to 90 degrees. The reason is very interesting reason is that in ammonia nitrogen undergoes sp3 hybridization, whereas in the remaining cases there is no hybridization, pure orbitals participate. Pure orbitals bond angles are around 90 degrees, and the angles given are ammonia 107.8, pH3 93.6, ASH3 91.8, SBH3 91.3, NCRT values. Okay, no need to by heart the values, just to see that down the group that the bond angles will be decreasing. Ammonia maximum. Coming to the most important property, that is reducing ability, reducing property. Nitrogen attached to hydrogen. If this hydrogen is going out, that's a reducing agent. But nitrogen hydrogen bond is strong, so it won't go. Bismuthine, BH3 bond is weak, so it can go out easily. And when bismuth hydrogen bond is weak and it can go out easily, when it can go out easily, it's a good reducing agent. So down the group, the reducing nature increases. Very important point. Down the group, reducing nature increases. Ammonia least, BH3 is highest. Then coming to the most important another property, that is Lewis base character. Lewis base character means nitrogen will be having a lone pair of electrons. Same thing, phosphorus, arsenic, antimony, bismuth, all they have lone pair of electrons. If they can give the lone pair of electrons, they can function like Lewis bases. Lewis base means electron pair donor. And ammonia is best in this case. Down the group, this will be decreasing. Ammonia best Lewis base. Why? How can ammonia function like a good Lewis base? Very simple. In ammonia, nitrogen size is small. When small size is there, nucleus power is more. When nucleus power is more, it can donate the electron pair for dative bonding easy. When it comes to bismuth, size is very big. When the size is very big, the electron pair is distributed over large surface area where the nucleus power is not much. अगर न्यूक्लियस पावर ही काम नहीं कर रहा है तो उसको डोनेट कैसे करेगा? नहीं होगा. That's not possible. So gone. So bismuthine is the least in Lewis base character. Ammonia is the best. So you will be asked about the bond angles, bond energies, bond lengths, and what you say, Lewis base character and reducing nature. One more is hydrogen bonding. Because of hydrogen bonding, ammonia boiling point is actually it should be less, but least is phosphine, then arsine, then ammonia, then stibine, then bismuthine. Okay. So ammonia will be in the middle, phosphine least, then arsine, then ammonia, stibine and bismuthine. Fine. So this is about hydrates. Hydrates, these points are very important. Along with this, you can see N2H4 and one more is P2H4. N2H4 is hydrazine, P2H4 is diphosphine. Along with this, one other special property is that is oxidation states. Nitrogen being non-metal, it can show negative oxidation state -3 possible. Ammonia, N2H4 -2, NH2OH -1 hydroxylamine, N2 0, N3H hydrozoic acid -1/3, N2O laughing gas +1, NO nitric oxide +2, HNO2 nitrous acid +3, NO2 nitrogen dioxide +4, HNO3 nitric acid +5. So from -3, -2, -1, -1/3, 0, +1, +2, +3, +4, +5. Okay, all these are possible for nitrogen. You can expect all these, almost all these for phosphorus also, but not so easily like nitrogen. And when it comes to the bismuth and all these in the negative states are not possible. In positive states also, down the group, higher oxidation state stability decreases. Which is higher oxidation state? +5. So +5 you don't expect for bismuth. The reason is inert pair effect. So higher oxidation state stability down the group decreases. This you can notice in Group 13 elements, group 14 elements, and group 15 elements. Group 13 elements are boron, aluminum, gallium, indium, thallium. In thallium, plus 1 is more stable than plus 3. Group 14 elements are carbon, silicon, germanium, tin, lead. Lead is more stable with plus 2 than plus 4. Group 15 elements are nitrogen, phosphorus, arsenic, antimony, and bismuth. Bismuth plus 3 is more stable than plus 5. So, plus 3 stability down the group increases, plus 5 stability down the group decreases, minus 3 stability also down the group decreases. Very, very, very special oxidation states. And when it comes to the oxidation state, one general point is to be noticed, that is, if the lowest oxidation state is there, let us say nitrogen, minus 3 lowest, highest is plus 5. If it is the lowest oxidation state, it can't go down. Already lowest state can't go down. When it can't go down, it has to come up. That means it has to undergo oxidation, so it's a reducing agent. Got it? When it is at the lowest, it can't go down. That means it has to come up. So when it is coming up, it is undergoing oxidation, so it is a reducing agent. So in the minimum oxidation state, any element is a reducing agent. Let us say highest oxidation state. You can't go up because this is only highest. So it will come down. Decrease in oxidation state is reduction. When it is undergoing reduction, it is an oxidizing agent. So ammonia is a reducing agent. HNO3 is an oxidizing agent by oxidation. Okay, now oxidation number, we are saying this one. Remember this point, this is going to be very, very important. Okay, so uh, oxidation states point of view, not only for this, any element you take, HClO4, chlorine plus 7, highest oxidation state, so oxidizing agent. If it is in the highest oxidation state, it is oxidizing agent. If it is in the lowest oxidation state, it is reducing agent. Remember this point. What happens if it is in the intermediate oxidation state, like NO2, like NO, like HNO2? When this is present in the intermediate oxidation state, it will go for disproportionation. It will, okay, it will go up, it will go down. Okay, now for example, this is intermediate state, it is going up, it is going down, both are possible. Okay, it can go down, it can go up. So in such kind of cases, the reactions are called disproportionation reactions. Disproportionation means increase is possible as well as decrease is also possible. And in all the intermediate oxidation states, you can expect the what is it? Disproportionation reaction. And for you, the reaction given is HNO2. HNO2 nitrogen oxidation state is plus 3, converts into HNO3 where nitrogen oxidation state is plus 5 and NO where the oxidation state is plus 2. Same reaction we were discussing in Ostwald's process also. In Ostwald process, NO2 will be formed. That NO2, when you are adding water, that turns into HNO3 as well as NO. That is also disproportionation. NO2 plus 4, HNO3 plus 5, NO is plus 2. Okay, so increase and decrease both for the same atoms. In such kind of cases, you can say it is disproportionation. Higher state, it is oxidizing agent. Lowest state, it is reducing agent. Intermediate state, it can go up, it can come down. In such kind of cases, it can go up, it can come down. In such kind of cases, the reaction is said to be disproportionation. If you are listening to me now, if you have any doubt, please post a message. Okay, so that it is a discussion time actually. I was teaching the same topic in class today. I just wanted to give for those who are absent in the class. If you are one of them, if you have any doubts, you just post a message. Okay, group 15 elements we are discussing general properties, and hydrides we have discussed. Along with these hydrides, we can go with oxides and all. One part we will discuss today, that is along with hydrides. Now we'll discuss about oxides, and after oxides we'll conclude this part. Hope it's 20 minutes. Okay, in live. In another 10 minutes we'll conclude this one. Tomorrow I will take another session. Okay, in that oxy acids of phosphorus, and one more session we will conclude this one. That means in 1.5 hours group 15 is done. आराम से listen sir, listen, you can listen anytime, just on it. इधर तो घूमते घूमते वॉकिंग करते हुए you can listen. Okay, whenever you are free, you just if you are a teacher, if you want to remember all those points, just on it while you are driving. Otherwise walking, if you are a student, you can listen. No doubts, because I am going to say The very, very important points which are required for all NEET, IIT exams, NEET and IIT exams. Then, so coming to the oxides, nitrogen forms wide variety of oxides, five oxides, but we discuss six, right? Five oxides, but we discuss six. First one is N2O, second NO, third is N2O3, fourth one is, hello, Priya madam. Fourth one is NO2. NO2 dimeric form is N2O4, and last one is N2O5. See, N2O, NO, N2O3, NO2, N2O4, and finally N2O5. So about all these one by one we'll discuss. First, N2O. N2O is called laughing gas, nitrous oxide, N2O, where the oxidation state of nitrogen is +1. Direct question. N2O, nitrogen oxidation state is +1. How it is prepared? N2O is prepared by heating NH4NO3, ammonium nitrate. On heating ammonium nitrate, you will be getting there N2O. N2O is a diamagnetic, colorless gas. Diamagnetic, colorless gas which is neutral in nature. That means if you are going to drop this in water, nothing will happen. When you drop this in water, no acid is formed. So it is neutral. N2O is neutral, diamagnetic. Preparation, you can prepare it by using NH4NO3 and heating is N2O. Okay, you can try in lab also because it's laughing gas. I think you have watched that movie, Sai, Rajmouli's. Nowadays, everyone knows about Rajmouli after that Bahubali 1, Bahubali 2, and Triple R movie. Okay, before that only, he is a wonderful director. In Telugu, he made a movie called Sai. It's a sports backdrop movie. In that, he has used this one, laughing gas. Okay, when laughing gas comes, you will be laughing, like a hysteria patient. Okay, hysterically you laugh, and finally, if the quantity is more, it leads to even death also. And long back, N2O was used as anesthesia. Okay, now up to some extent it's okay, but if it goes more, fasak. Okay, now not too many fasaks, only one time fasak. Okay, now N2O, not so much. So N2O bonding N, N, O, N triple bond N, single bond O. Otherwise N double bond O. Two types of structures are possible. You can just check in NCERT. Here NN bond is there. You can notice this point better because the question will come in how many of the following NN bonds are possible. Here it is possible. N2O, NN bond is possible. So this is all about laughing gas. After laughing gas, we have NO, nitric oxide. Nitric oxide oxidation state is +2. Nitrogen oxidation state is +2. If you have any doubts, you can post a message. I will clear your. I am here to talk to you, not to teach. Okay, if you have any doubts, I wanted to explain. If nothing is there, I just wanted to mention this group 15 elements. Whatever the topic doubts are there, any topic. Okay, if I know, I will explain. Okay, otherwise I will check and explain. No problem. General doubts and all chemistry only related to chemistry, please. Right. So N2O, after that O, N we had in NO. NO is called nitric oxide. Nitrogen oxidation state is +2. NO is also neutral. Okay, but NO is paramagnetic due to the presence of one unpaired electron. N double bond O. You can keep a lone unpaired electron on nitrogen, or you can keep it on oxygen, no problem. But here one very special thing is there. You can even show a 3 electron bond also. You can show even a 3 electron bond also. So whenever this question comes, which of the following has odd electron bond? Odd electron bond means you can go with this. Okay, odd electron bond means you can very comfortably go with NO. Nitric oxide, how it is prepared? N2 plus O2 gives rise to NO. Do you think that this reaction really takes place? What I am inhaling? Air. What are present in the air? Nitrogen and oxygen. Do they react? Normal conditions, they do not. They react only at 6,000 to 7,000 voltage, very, very, very high voltage. When this thundering will taking place, na? Rainy season, thundering. If you are a Mangalorean, okay, Mangalore is a wonderful place to go, man. Because I was there for 1 year. In Mangalore, when it rains, na, we generally get a fear. Okay, the rain won't be like rain; it will be like da, 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 da. And when it's that kind of all the Nilgiri hills area is there, na, so there, not only there, whenever thunderings and all are there, in the thundering and all, very high voltage will be produced. In that, nitrogen can join with oxygen to form NO, not regularly possible. Okay, NO, nitric oxide. Otherwise, you can prepare. Let me check because I should not miss any single line about this nitrogen oxides. That is NaNO2 given to you, sodium nitrate and FeSO4. On this reaction also you can get NO, nitric oxide. But N2 plus O2 NO, you can very comfortably remember. This was given in NCERT, so I was telling you. Then 3 electron bond is speciality. It is paramagnetic, colorless, and neutral. Okay, that's about NO. Next, N2O3. N2O3 is nitrogen sesquioxide. Okay, nitrogen sesquioxide. So Al2O3, N2O3, P2O3, these kind of 2, 3, these kind of oxides are called sesquioxides. Dinitrogen trioxide or nitrogen sesquioxide. Here it is N2O3. This is diamagnetic in nature but acidic. Diamagnetic because no unpaired electrons are there, but it is acidic because when you drop this in water, it forms HNO2. HNO2 is a nitrous acid which is unstable, of course. Nitrous acid is unstable, but when you drop this in water, it forms HNO2, so it is acidic in nature. And when it forms HNO2, you can call this as anhydride of HNO2. So N2O3 is anhydride of HNO2. How it is prepared? Simple. You need N2O3, right? N2O3 you need N2O3. So you take NO, NO2, NO plus NO2, that means N2O3. Okay, so NO plus NO2 gives rise to N2O3. And N2O3, when it is dropped in water, it forms HNO2, nitrous acid. Nitrous acid is an acid, so it is anhydride of nitrous acid and it is acidic in nature. It is also having a bond NN. Okay, NN bond is there, and one oxygen give double bond. Nitrogen single bond is there for one nitrogen, one double bond oxygen, one single bond oxygen. Another nitrogen you can give double bond. But what I suggest is, okay, I have seen another books. Okay, I am not suggesting from my own. NON bond is also possible. N O N, then double bond O, double bond O, O double bond N, single bond O, single bond N, double bond O. This is also possible. But NCERT it is given NN. So whenever the question comes NN bonds means you can go with this one also. Right? So this is about N2O3, nitrogen sesquioxide, diamagnetic, acidic in nature. Direct questions, remember this. Next, coming to NO2. NO2 can be prepared by heating lead nitrate. 2022 JEE advanced question on heating lead nitrate gives lead oxide, NO2 paramagnetic, O2 another paramagnetic. The question was NO2 and O2 both are paramagnetic. It produces both paramagnetic, but of that which is having great magnetic momentum. Okay, now NO2 has 1 unpaired electron, O2 has 2 unpaired electrons, so more magnetic momentum is for oxygen. In that, how many number of anti-bonding electrons are present? O2 has 6 anti-bonding electrons. That's 2022 JEE advanced question. So coming to NO2 on heating lead nitrate, it will be formed. NO2 is paramagnetic because of unpaired electron. NO2 is acidic in nature. When you drop NO2 in water, it forms HNO2, HNO3. When it forms HNO2 and HNO3, you can call this as mixed anhydride. Mixed anhydride of HNO2 and HNO3. Okay. When this is cooled, it forms N2O4. N2O4 is diamagnetic, acidic in nature, and N2O4 is solid. Okay, in book it is mentioned even liquid also, but generally colorless solid. And N2O3 is blue color. Okay, N2O3 is blue color solid, and NO2 is brown color gas. NO2 brown color, but N2O4 dimeric form is colorless. NO2 brown gas, but N2O4 is colorless. N2O3 is blue color solid. So colors, everything is important. Important. You can't skip anything. So that's about NO2 and N2O4, the differences and all. Structure if you want nitrogen. One electron will be there on nitrogen, single electron, double bond O and dative bond. When you join these two NO2 groups, that is N2O4. NN bond, double bond O, single bond O's. Right? So last 2 minutes, then I will wind up this one. Already 30 minutes over. So 50% of the lesson almost we have covered. Group 15 elements. Last one, N2O5, dinitrogen pentoxide. How it is prepared? Take HNO3, remove water. For removal of water, you can use P4O10, good dehydrating agent. Water gone. When water goes from HNO3, it turns into N2O5. Okay, that means when I add water, N2O5 will turn into HNO3. That means it is anhydride of nitric acid. Anhydride of nitric acid. It is diamagnetic, acidic in nature. Oxidation state is +5. Okay, highest oxidation state +5. N2O +1, NO +2, N2O3 +3, NO2 +4, N2O4 +4, N2O5 +5. +5 oxidation state. Fine. So क्या होता है इसके बाद में? When you drop it in water, it forms HNO3. So anhydride, it is prepared by removing water from that structure. NON, N-O-N, NON. Then each nitrogen, you can give double bond oxygen, single bond oxygen, double bond O and dative bond. This is about the oxides. Okay, now. And N2O5 is also colorless solid. Oxidation state, structures, and everything about the nitrogen oxides we were discussing. Phosphorus. Okay, now phosphorus, two oxides we discuss. P4O10, P4O6. Both are acidic in nature. P4O6 +3, P4O10 +5 oxidation states. So obviously higher oxidation state, more acidic in nature. So P4O10 is more acidic in nature. And the structure point of view, they can ask you how many POP bonds are there. Remember, in P4O10 or P4O6, both structures will be almost same. There will be simple. See, P, 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 and P. 4 phosphorus you keep like this. Join them by oxygens. Okay, join them by oxygens. So there will be 6 POP bonds. POP, like that 6 bonds will be there. No PP bonds. Each oxygen 2 lone pairs. Each phosphorus 1 lone pair in P4O6, P4O6, P4O6. I repeat, P4O6. In P4O6, each phosphorus 1 lone pair, each oxygen 2 lone pairs. So total 16 lone pairs will be there. POP bonds will be there, and PP bonds are not there. Similar structure you can expect for P4O10. The only difference is there will be extra bond between phosphorus and outside oxygen. You can show it by dative bond. Some books it is given by double bond. Earlier it was double bond, now it is shown with a dative bond. Because when it is shown with dative bond, all atoms are with octet configuration. Nowadays we are getting structures like that. Right? So thank you all. This is my first live class. Live class I am saying. Okay, now live sessions were there, but this is my first live class. So signing off. Whenever time permits, I will try to explain each and every lesson which is required for all engineering entrance examination, medical entrance examinations. Whenever you have time, if you like this video, please do subscribe, share, and watch it continuously. Okay, now there are so many videos in my channel. Around 1200 videos are there. So many questions, so many concepts. I think you won't be disappointed. Okay. Like it, share it, comment. Okay, now any doubts, you just please mention a comment. Okay, positive comments, negative comments. Okay, no abuse, please. Okay, thank you all. Arya, how to end up?
Go to reception.